Okay, let me go ahead and welcome all of you to the uh, Frontiers in Mechanical Engineering and Sciences seminar series. So this is the first seminar for spring semester. And just a reminder, this is a multi-university webinar series, which has now more than what you have on the list here with the logos. There are 13 different universities which are participating in this seminar. And I'll take the opportunity to thank all the planning committee members, and most importantly, the three members we have, Professor Edgar from Princeton, Professor David Go from Notre Dame, and Professor David Bogart from UT Austin. So this time we are trying a new format compared to last semester where we had paired two faculty members from each institution depending upon their thematic alignment. We will continue with that format, but we are also introducing distinguished seminars in each month. We will have one speaker each month. And today it's a great pleasure. We have our first speaker, Professor Ajay Malshe from Purdue, but I will leave that introduction to Professor Shreyas Melkot from Georgia Tech, who will be our moderator for the session today. Professor Melkot is Maurice M. Bryan Junior Professor in School of Mechanical Engineering, and he's also Associate Director for Georgia Tech Manufacturing Institute. More than that, he has been a great mentor for me, and whenever a chance it happens, I like to thank all my mentors who have supported. So thank you for that. This is more than a seminar; it's also mentoring for junior faculty who will be part of this. So Shreyas, it's all yours.
Well, thank you for that very kind introduction, Devesh. It's my pleasure. So good afternoon, everyone. It's my pleasure to actually serve as a moderator for a seminar by a good friend and colleague, Professor Ajay Malshe. I'll give a brief introduction before I turn it over to him for his presentation. I think just as an announcement, I think I was told that if there are questions, please at the end, please post them to the chat. I'll read them out so that the questions get recorded. And then, I guess depending on the number of people that show up, if you want to actually, join the conversation via video as well, you can turn your video on when your question's being discussed. So without further ado, let me introduce Professor Malshe, our distinguished seminar speaker today. Professor Malshe is the Eugene and Susie E. Goodson Distinguished Professor of Mechanical Engineering at Purdue University. He joined Purdue quite recently from the University of Arkansas, where he served as Distinguished Professor and 21st Century Endowed Chair Professor in the Department of Mechanical Engineering. He's internationally renowned in the field of advanced manufacturing, and his work focuses on bio-inspired micro and nano manufacturing, material surface engineering for tribological applications, and system integration. He has received numerous honors, too many for me to list here, but I'll just highlight a few. He's a fellow of the International Academy for Production Engineering, commonly known as SERP in the manufacturing community. It's headquartered in Paris, a worldwide body of distinguished researchers in the manufacturing area. He's also a fellow of American Society of Materials, American Society of Mechanical Engineering, and the Institute of Physics. By training, if you didn't know, he's actually a physicist by training. In 2018, he added to this list of honors by being elected to the National Academy of Engineering for his innovations in nanomanufacturing with impact in multiple industry sectors. And I certainly can attest to that. I've known him for a number of years and interacted with him at various meetings, and I certainly hold him in high regard for all his accomplishments. So Professor Malshe has trained more than 60 graduate and postdoctoral students, published over 200 peer-reviewed manuscripts or papers, and received over 20 patents and numerous awards, not only academic awards, but also industry awards. A distinguishing feature, at least in my mind, of Professor Malshe is that he's actually as much of an educator, as much of an entrepreneur as he is an educator. He's one of the few people I know who has taken science in the laboratory all the way to commercialization to the point of having broad, widespread impact in industry. So I think that was one of the reasons he was elected to the National Academy of Engineering. He serves multiple professional organizations through his leadership roles on various national and international committees. And I'll keep it at that. His resume and CV and accomplishments are too long to list here. So without further ado, I'd like to turn over to Professor Malshe. I'm excited to hear about his thoughts on his seminar, which is titled Co-Audimus, Engineering That Matters, Manufacturing Leadership and Equity. Professor Malshe.
Thank you. Thank you, Professor Melkot, for the introduction. I truly appreciate that. I hope you can see my slides. So, Devesh, can you see this? Give me a thumbs up.
Yes.
Perfect. Thank you. So, Shreyas, thank you for your generous introduction as well as your friendship over many years. This has been a very exciting time. But as much as I would like to talk about some exciting research in new science, I thought the times are very interesting right now when this talk is being arranged. And I would like to thank my colleague, Professor Partha Mukherjee, and Professor Devesh Ranjan from Georgia Tech for inviting me. I can see many old friends, new friends on the call, so thank you all, including especially ASME, that is one of the closest organizations I work with. Today I decided that I will take this moment to talk about a topic, partly which could be uncomfortable, but through the uncomfort and through the challenges, we discover our way out. So I thought with all the brilliant minds in the, if I may call in the room, because we are in the virtual room, why don't we talk about something which really each of us could be a part and need to be a part as we go forward, especially as we pull ourselves out of this COVID pandemic. Before we start, I would like to share a disclaimer that as I'm working from home office, we have a very new pet at home. And so if you hear any background noise, I welcome you to ask me any question about the pet. I will be happy to share. But with that, no more further delay. The topic is engineering that matters, because over the career, what I learned and what I felt is I believe that we are in a very asymmetric as well as symmetric society of nature, human, and bits. And so with that thesis, I would like to share, and Shreyas as well mentioned about my participation in academia and industry. So my learning over the years is what brought me to this point, what I'm about to share with you. These are a few of my backdrops you already heard, and I will pass these further along. But where are we going? So let's take a pause and let's journey this together on the talk today. I would like to take a look in the hindsight where we came from. So as human went from hunter-gatherer, became domestication, from animals to grains and variety of other things. Every century has named behind materials. So materials became enablers, and manufacturing process became the deliverers of various ideas, innovations, inventions, all the way from Stone Age to copper, bronze to iron to silicon, and now we are in the dimensionality. So after exhausting all the periodic table in X and Y dimension, we decided to explore ourselves in the axis, which is the size of it and the dimensions. So as we are continuing to build the three-dimensional periodic table, I also realized that this has all taken us to the point where we have taken the fundamental chemistry, then we have combined those with the constituents of that chemistry, when we call stoichiometries further along, and then we have architected ourselves out of forms. So we really combine chemistry, constituents, stoichiometry, and form to start building what we call manufacturing, and going towards the manufacturing of multifunctional materials. And that becomes something very important. Towards that, it also became very important that how we have gotten to the point of industrial revolution in the recent times, not far out, in just maybe over a century or so. So we went from mechanization to electrification to computerization to now going to datafication. But really, as a human race, we got into the race with ourselves for good, more, fast, and cheap. And that race is continuing to put us further and further along. As we are continuing to race with ourselves, we are also building the world which is hyper-connected. It used to be hyper-connected before even. In the late last century, the world was hyper-connected physically. Now we are hyper-communicated as well. And as well as it became hyper-complicated with combination of physical and data. So you're really in a very highly complex, symmetric and asymmetric society of connectivity, communicability, and complicated connections and nature of this. And on the top of that, we have serious growing population. Now, so just to look in hindsight where we came from to industrialization, digitization, what we call sizification or micro and nano scale, what we reached to at, digitization and becoming additive, subtractive, and transformative processes. Then further along and continuing to develop the autonomous system and intelligence, and then challenging our own intelligence, human intelligence, to take a benefit from artificial intelligence. So we are really accelerating the speed of automation and human demands in hyperuse, not only of soft features, but as well as materials, energy, manufacturing, and digits. And this is becoming a very interesting conundrum because what it is leading us to is technology which is driving the inequity. When the subject of equity, equality used to be discussed, these used to be economists, social scientists, but to my discovery, it is really becoming highly technological issues, and let's talk about that. So the next step in that, I would like to highlight some of these facts, what has happened in the last more than quite few decades. That in America, 1% has taken 50 trillion from the bottom 90%, and there is a very fast growing inequity and inequality gaps in economy. On the right-hand side, you're seeing some of the statistics, and that statistics is pretty intimidating as you look at two things, inaccessibility as well as inequity. Now, when this is all happening, this actually happened during the COVID-19. But even before that, this happened, with average capita earning of $36,000 in the United States. On the top, what we are looking, the stock market is booming. If you look in the last just few years, what happened? Companies like Tesla has came to the fusion, and the 5G network has been advertised everywhere. At the same time, when we are inventing ourselves with the latest and the best to deliver it to the world and the nation, at the bottom, our fellow citizens in the very United States, from schools to colleges to the urban as well as rural deserts of America, have been going through this. And when this was all going on, what people are also realizing that only few people can participate in the stock market. Only 55% of the American population can invest in the stock market. So what we are inventing and discovering, and the tech markets are taking us further along. Not 50% of America can participate in, but they are the taxpayers who are paying my research. So when this all was going on, what happened is that we had a health quake, just like an earthquake. And that started showing us, what it started peeling off, is the gaps, the layers, the cracks in what one may call resilience. And so this earthquake of health, or you may call healthquake, has really shown some very interesting observations. This is one of the historic times for a scientist and engineer to observe and connect the dots. And I'm really finding this time very, very eye-opening. Because one thing that became clear to us, and this is from early, and you have seen this, and I would like to put a meaning to this, that COVID-19 and mask, and the mask became the best technology that can work with people. but that has saving billions of lives as well. Pardon me. When this is all going on, what I find very intriguing that 100 years before, when the flu pandemic hit America, and then 100 years later when we are in COVID-19, in those 100 years, at both the ends, the mask was the only technology that helped the population the most and the best. And so what is the purpose of technological advancement? I kept asking to myself that I work in nanotechnology, additive manufacturing, subtractive manufacturing. What is really the purpose of this all? When there's equity gaps, when there are challenges like this, but what is telling me what is working and what is saving lives in this kind of situation, how can I do what I do? Because when I read this, people may have invented or discovered the cures for the pandemic, for the virus, but the deliveries are taking time, the manufacturing is taking time, the number of deaths are going up, almost 500,000. We are crossing or already crossed the Second World War numbers. So when this all devastation is going on, if the mask is the only solution that is coming to the handy, and despite all the great science, the engineering cannot be executed, I started wondering to myself, where are we going? And that's where it started. And when this all is happening, I also saw another interesting fact that just during the pandemic, and this news is from last week, when this all pandemic is happening, when 46 people joined the ranks of billionaires since March 18, 2020, and I hope some attendees on the call are part of that. I really hope some of the scientists become one of those. The 2.4% during the second half of the year, nearly double the last annual increase since 1960. And if you look at these entrepreneurs, they are all technology. They are all working on additive manufacturing, cybersecurity, going to space, autonomous vehicle, batteries, electricities, and every aspect that is being funded by science and by engineering nationally. So the question one need to ask that how technology inventions and discoveries that we believe can help the society and create jobs are really causing the inequity gap. And so inequity is no more socio-economic challenge, but inequity is a techno-socio-economic challenge. And that's something very revealing during this. So our society is typically our reflection. And are we engineering and investing in it what matters to the society as a whole and not to the few? Because it is not about who is billionaire and who is not. It is about that can we take all the society or the most society with it, where everybody get a fair chance for upward mobility. And that's what it is about. And can we as engineers, so it is a calling for me, and I wanted to share this on the call today. Going forward, but when you're looking at all these challenges, problems all around us, let's start thinking that how challenges can become an opportunity. And there are many first-generation immigrants on this call as well, as intelligent scholar faculty. And people can attest to that. Being as an immigrant, challenges become your problems, and problems become your challenges, both. And so let's think that and think ourselves that how we can build a human-centric industrial revolution, where with growing population, which is going to reach about 9.4 billion, maximum capacity that we can consume most of the resources on the earth in the next few decades. How can we build a human-centric industrial revolution? So are the technologies that we are working on, are the technologies that would help us, or they would continue to create this gap? Or do we need to take a pause and think to ourselves that what can I do differently? So this next part of my talk is to start looking around, that to look for solution. How can I think outside the box? So when I was thinking about that, as I mentioned before, that what I saw and when I looked at the Maslow's hierarchy of needs, I realized the challenges are right at the bottom: food, agriculture, health, basic human safety. But going to the Mars and the space and the moon and all the exciting things that tantalizing that I can publish, I can patent, I can commercialize, still are many at the tip of the triangle. So really we are becoming a hollow in the base and rich in the tip. And that is an unsustainable. And so the problem is a very convergent problem of technology, society, and economics together. And one may add even health sciences to this. So if the problem is convergent, then the solution will be convergent as well. So it's important to mention that the problem is a convergent and the solution must be convergent. And I'm sure all of you, or many of you at least, read about the convergence. So it is about tackling the complex challenge. And I believe that this is a very complex challenge. And to work on this complex challenge, I always found out that some of the most difficult problems, the solutions can be extremely disruptive, but could be very, very in front of us. So with that question, I started looking around us, and I started looking at nature as an engineer. What matters to survive? Because one thing I found out, that the challenge is not we don't have a solution. The challenge is that are we looking for solutions? And with that, I started looking at nature as an engineer and what matters. Because in the nature, to survive and thrive and to give fair chance to all. So in the farm, if there is a rice plant or a corn plant, but there is a weed also, and they both have a fair chance to grow. So there is no discrimination in that sense. But at the same time, that in nature, I've seen the diversity, it lives in balance and very harmony. So I felt very exciting that I can learn from nature. The word at CIRP that Professor Melkert spoke about is CIRP. We call it a biologicalization. So biologicalization, I found, is a very exciting opportunity to learn about convergence, where we can talk about bio-inspired, biomimetic, bio-integrated. And bio-inspired doesn't mean that I'm only going to take design. I would like to think how nature thinks. How nature thinks about the word resilience, because nature has gone through millions of years of difficulties and still survived and thrived. So learning the models, even of processes, systems, system of systems, I found nature as a very exciting opportunity going across all the skills. With that, I also found out that nature is a great engineer. Means if you look at examples and superimpose on top of that, means the smallest machine that is nature made is a virus, and it is a bacteriophage which kills the bacteria. It is a perfect robot with a spring, with a landing pad. It looked like a Apollo 13 moon lander, in fact. A sensor right here, a head which carries the RNA, a brain which is highly complexly networked. And so I find that before I look for artificial intelligence, how can I look for the intelligence that is around me? And I'm part of that, in fact, and I can learn from that. Why? Because nature manufactured about 8,000 species all the time with very high precision, scalability, and all the things that one can imagine. And so with that, I started looking at nature as something, as a mean of learning what really convergence means. So convergence for me is not about a solution. Convergence is, for me, is about problem. And for that convergent problem, if I can have a convergent approach, is what is very exciting. So when you look at nature as a convergence, I'd like to share, as I mentioned, that my purpose of my talk is not to share just my own result, but I would use 3 anecdotal examples from my group with collaborators, some of them on the call. So first example is looking at nature as a manufacturing toolbox. And if you look at the nature as a manufacturing toolbox, how nature can manufacture 8 million species with the highest consistency, with highest sustainability, minimal usage of the resources, and the maximum usage of the functions to build a resilient system across the length scales, across the signals, so highly heterogeneous in materials, signals, processes. And I found out with my colleagues that part of their toolbox is you have multiple of these tools that nature has used very cleverly to build the surfaces, those are very exciting. And using those and the critical physics that goes with it, like a magenta butterfly wings, you can make structural colors so you don't have to use certain chemicals. You can build enormous number of exciting products. We are just not even starting on this. This is very much at the nascent stage, still where this can go. The second example is that if you are working with the biological inspired designs, you can learn from nature. On the top left, what you're looking is the ventral scale on a snake skin. Snake is an example in the nature of soft robot. So if you're building a soft robot from the polymer, you have an example in the front, which is a snake. And the ventral skin of the snake has this denticulation. Those are aligned along the axis of the snake, and the snake manipulates the coefficient of friction in one of the movements, which is serpentine motion, where you can achieve that very precisely. And using 3D printing, you can print these kind of structure very anisotropic, and then can achieve these sinusoidal patterns of the coefficient of friction, and then can replicate those templates on a soft robots. So as I mentioned, that nature is a very important, over more than decades for me, a learning medium, a very effective one. The third example is resilience. As I mentioned, nature is a very great resilience example. Nature has used multiple of these tools. What you're looking is nature's resilient toolbox for building a very resilient system and system of systems. And in that, one of the things I found out, a large similarities and the cleverness. When we are talking about COVID-19 virus, I hope some of you has studied the design architecture of that. The design of architecture of COVID-19 is one of the most simplest, but one of the most cleverest design that you will find out, and the similar patterns of those design can be on pollens as well as dandelions. So nature has used some of the very sustainable, very attractive, and very aesthetic some of the designs to build the systems. Those are very resilient. And on the top left, you will find out how resilience is developed. Because society, what failed in this time is the resilience of the system. So with these three anecdotal examples, I would like to continue this dialogue further along. And in that, what I find is what we learn from nature. I find myself 5 things learning from it. Learning how to learn and apply resilience, frugality of innovations and engineering, affordability and multifunctionality, accessibility to technology for all, and techno-socio-economic equitable society for all. This problem actually is now far more important additionally as an educator for me, because when I look at the statistics among my students, the very students I'm teaching today, I find that there is a very important trend in the Generation Z and the generations to come, that wide the challenges of gaps that we are talking about are highly precedential today, because the texture of the student body is changing dramatically. So with that, I decided to start looking at the solution now with nature, that we're human having a very important part of this thinking simple, but being very effective. So with that, this is Friday afternoon, so I decided to take a little detour in my presentation and talk about food. One of the things I found very common in all street foods from every country. So people may like some countries, may not like some countries, but the food, street foods, especially from most of the countries, from Japan to Mexico to America to India to every part of the world, are very, very popular across the globe. And what I learned from that in Frugal Innovations is the foods on the street are frugal engineered under very highly resource constraints by the vendors. They're invented by millions. They are driven by the market pull. They are feeding the large customer base, and they are mass scale customization. And this is very interesting learning for me as a manufacturing engineer and as an entrepreneur. So with that, I looked around the world at where are these examples in the nature, and what I found out, the examples like this, that there is no patent, there is no what you would call any intellectual property per se, but there are very serious problems people have been solving. This is examples in Peru for water capturing net using super hydrophobic structures of the net and gravity fed to collect the water for a large population for drinking and farming. Today, if you may not know, in Navajo nations and many parts of the country and not far from here in Indiana, in Chicago and other parts, water is a big problem. So when we are running engineering research centers in water and other, our fellow citizens at many places cannot afford to have water every day. At the same time, these are the plastic bottles on the road in Philippines, were effectively used to provide lights to people, those who live in the shack, and giving an opportunity for students to study in the daytime so they can have upward mobility in the society. Examples from northern Nigeria to extend the life of food during the farmers, so potters can get more jobs, farmers can get more crops, and household can extend the life of the leafy vegetables. And this all has been done using very simple science, but highly effective science to apply that to people. This is an example from middle ranges of Himalaya, where it is the Himalaya, if you have not been there, if it is really a large body of rubble. And in the middle ranges of Himalaya, despite they get snow, during the springtime, it all melts away. And this is an example of ice Stuka, which provides water for farming during the spring and early summer. So when I studied this example for the last few decades, I came to the conclusion, and this is extremely dense table, and I must apologize for that. But I would walk you through what it is about, that these are the innovations on the top. These are the specific locations, and I did give you some examples of that. There is a very good amount of science engaged in all of that. There are community engagement as well. Very important part of this, that there is a large community engagement. So the science was applied in symbiosis with the community. The affordability and accessibility of this was incredibly high. And then it has a very high impact on individuals' lives. And then each of these innovations have received highly prestigious award and recognition. So just because they have been done frugally, frugal doesn't mean cheap. Frugal means frugal innovation is probably one of the most difficult to do rather than anything. They have even received, in some cases, Nobel Prizes, as well as the Rolex Awards, which are very prestigious, including in the NA's Green Journal. So I wanted to highlight that how we can think different. In that message of difference, this is the frugal engineering and manufacturing model that we came together. First, it is simple in science and engineering. Second, it uses locally accessible materials and expertise. The manufacturing is done using components off the shelf, COTS. It is open innovation because if you go back in the history of the United States, you will find out the early inventions by Benjamin Franklin and some of the inventors and innovators were not patented. The idea of patenting started somewhat later when corporations wanted to, and individuals wanted to protect their property and not to have accessibility. And today, the number of patents have grown exponentially. Sometimes the open innovations, all the innovations that you saw before that has helped millions of people are all open innovation, just like open source codes. Participation from citizens experiencing inequity, they are the part of these innovations, so they are brought into the process. And maximum effectiveness, so not necessarily very efficient, but they are maximum effective as well. And right-hand side these are some of the very important attributes of that, including the very, very low carbon footprint. And that is something important from the sustainability matrix. So with that, these are the pictures. I wanted to put the pictures of these innovators. The innovation that came from Brazil, so this is the innovator from Brazil, Philippines, Los Angeles, Mumbai, Bangladesh, northern Nigeria, middle ranges of Himalaya. These are all what I call servant leaders. So it is really a great example for many of the colleagues and the model that we really need to go after is that can we immerse ourselves with problems so we can invent what is relevant and engineering that matters? How can we serve the community, because our research, our education is part of the community? And then how we can be social innovators as well. So with that, the important question need to be asked that what are the major science engineering challenges in post-pandemic America and the world? And I believe that readiness for the next pandemic, because most of the pandemics came when human society interacted with the nature. Ebola came like this when the major freeways were cut through the jungles in parts of Africa. In COVID-19, there are different hypotheses, but it appears it came from human interaction with the nature. So with the human population growing and the more encroachment on the nature, it is expected, there was a good article in Atlantic recently, that the number and the frequency of pandemics will grow. So how can we be ready for next pandemic? So the social readiness, at the same time trustworthiness on science and engineering, which is equally important. We do quite a bit science. We really need to do more engineering, and then inequity are something important. Why? Because based in a social innovation after 100 years, what I cannot take out of mind is frugally engineered mass that rescued billions. So I would urge each of you to change how you think about an invention and innovation. Many a time I believe the national solicitation for funding almost program faculty and researchers on what should they think. But I believe what we should think is what is good for our communities and the nation overall. So with that, my request and urge to all of people and colleagues is let us invest in science what matters. Because our society, if it has to become our reflection and we want to see a good reflection, doing that engineering because it matters and investing in that and not only in science is very meaningful. So with that, I would like to thank you all for sharing your Friday afternoon and listening to where we are today and where potentially we can go. So thank you again.
Thank you very much, Professor Malshe, for that very interesting and inspirational seminar, getting us to think about the role of science and engineering in the context of society that we are part of. I'd like to open it up for questions. If you, as I indicated at the beginning, if you can post your questions on the chat, I can read it out. And that will ensure that we can do this in a streamlined manner. So perhaps I can initiate the dialogue here, Professor Malshe. I very interesting that you connected all the way from materials and manufacturing all the way to the notion of socioeconomic challenges that we face, and that technology's got a role to play. Hopefully I didn't misunderstand, but technology in my mind has always, served to try and improve the human condition. I mean, that's the role of engineering. Certainly, science enables that. Is the thesis here that the pace of technology has been so rapid that has led to inequity in society? I mean, are you suggesting that the pace of technology is so rapid that it has actually led to inequity?
This is an interesting question, and this is a dialogue. I'm still coming to some hypothesis and then trying to find the answers for that. So I'm not sure I have answers for that, but let me share observations, because as an engineer and a scientist, observations are meaningful. One thing I'm finding at this point in time is it is not the science that we are limited with. It is the affordability and accessibility is what we are limited with. Let's take an example that the kind of the technologies that we are coming up with, it is important for us to know that how individuals can have accessibility, they can participate in this, because the gap is coming because of participation. The second thing that is coming is that today, because of the digitization, even the foundation of the Maslow pyramid is connected to the digits. So being digital is not being technological. Because today how the manufacturing in the food industry happens is it largely happen digitally. If you today look at the e-commerce supply chain that delivers foods and other, it is all technological. So accessibility and affordability are far more important. It is not we don't have it. It is just the accessibility to what we have. It creates more gaps. And the second, lack of potential, you may call, lack of pathways, you may call, or whatever. People cannot participate in this. I'll give you an example today. That there are engineering research centers for water, and 500 miles away from that, there are people those who do not get water every day. Why? There are contaminations on the ground. So the second observation is that, are we working on the problem those who matter, or are we working on the problem those are at the top of the pyramid? So I believe that we are working on the problem those are at the top of the pyramid, but the problems are at the bottom. So we need to focus on both, right? Because we need to address both. But there is a higher amount of polarization which is being observed right now.
Well, thank you for that commentary and response. There's a question in the chat, so let me read it out. It's from Professor Partha Mukherjee, your colleague, and he asks, how can we bring the next technological innovation in an energy efficient and yet equitable manner?
So Partha, this is our dialogue for some time. And I truly believe that today, it is not we don't have energy sources. What we are focusing, again, I'm sharing observations. I do not have conclusions. But and as a dialogue, right? So my first observation is that we are trying to invent ourselves out of this challenge, believing that if we come up with the next material or a next battery or a next solar cell, which has a higher efficiency, but nobody's asking a question that what I need to have which has more effectiveness, including accessibility. If the panel of solar cell on my roof is going to be $20,000 to $30,000, with my annual earning of $38,000 per capita, can I afford it? And the good example in the nature, remember, best solar cells in the world are leaves. They take energy, they convert it for a purpose. Every year, literally trillions of them, they fall, and they become the part of the ecosystem, so there is no carbon footprint waste. Imagine the number of batteries that are about to come online. So we are we were energy dependent with gas and oil on the Middle East. We invented ourselves out of this with fracking, and now fracking being villain, we are trying to invent batteries. But then what is going to happen to the waste of the billions of hundreds of billions of batteries? They may land up just like our CRT screens in some rivers and oceans. So again, instead of one technology does not replace another. This is the rat race. This is the race we are in. We got to take a pause and see what effectiveness this has more than efficiency. So it's a change of the way you think, and not the way. We have pretty good talent, pretty good technology, pretty good science. We need to, for actually, I didn't go in detail, but for social innovations and frugal innovations, 4 R's are important, and think about that for energy: reapply, repurpose, reuse, and reconnect. And that's something important to think about, and not go and make something new to replace what we have. And that's how I would like to suggest. Thank you.
All right.
Thank you, Professor Malshe.
there's a question here. The frugal innovations, most of them are made by communities themselves who had resource constraints and a good understanding of their own problems. How can someone in academia come up with such innovations? I guess, or the approach to such innovations, without, I guess, knowledge or good understanding of the problems themselves. That's implied, I guess.
No, thank you, Abhishek. I really appreciate you asking this question. And this is something that has actually changed. I changed my own operational style and working style more than a decade before, because first I realized that I need to do two things with the problem. I need to live with the problem, and I need to almost experience it so severely so I can pull myself out of it. And I learned this in my earlier career. And so one of the ways I can suggest is most of these servant leaders that you suggested, like in Bangladesh or northern Nigeria, they lived in the community. They were the part of the community. They went and spent time with the community. Ms. Professor who has invented microloans in Bangladesh, he was well-to-do individual, but there was a second component for him was compassion. And that's what I use the word servant leadership. And if you are interested in any form of servant leadership, there is a good book, actually, I would be happy to suggest. But one important part, so I would ask many people a question, and it may not be a part of promotion and tenure today, but one need to ask a question that are you compassionate up to your fellow citizens? Because it is like saying that I see a great example on a Facebook that a father has made a 3D printed prosthetic arm for a child. There was no community involved, but there was an important ingredient involved, that there was a compassion. I love my child. I really want to give my child abilities. And I wonder, and this is what the calling I felt, that I need to feel compassionate about individuals in my society who has no voice, because these are silent problems. How many times you would find out somebody who has nothing has a voice? And so as a scientist, I feel that if the problems at the foundation of the Maslow pyramid, if they are connected so closely now to the technology, as a technologist, I need to be connected with this. I need to understand these problems. So I would suggest travel, visit, spend time, and be a part of that. And that's something I find is very important, that to be a part of that in immersion. I suggest serious immersion is a very important model to come up with impactful engineering. Thank you.
Thank you. Please keep typing your questions into the chat. So to continue the conversation, and Devesh, you'll have to let me know when time's up, and I'll continue the conversation.
So maybe, Ajay, I'll change the subject from social innovation and let's talk about the bigger picture about future of manufacturing. I think because of so many things changing in DC right now, where do you see our economy perspective? What do you think manufacturing can help in some of these climate change technology which will be coming out in the next 5 years? How do we ensure that US is at the top of those innovations and also translating that in the manufacturing sector?
So thank you, Devesh, that you asked that question. I had slides and I decided not to discuss that topic. So I must put a disclaimer before that I do not belong to any political party, and the statement I'm about to make does not have any political, or neither it represents Purdue. It's just my personal observations. And my observation is that as a country, we have 3 academies: science, medicine, and engineering. But we only have 2 agencies, science and medicine. We left engineering. Historically, if you go back, we used to have IBM Yorktown Heights. We used to have Lucent Labs. We used to have our AT&T Bell Lab at Murray Hill. We used to have HP Lab, IBM Almaden. So the corporate houses have taken the role of engineering the science. That's what the role was. As soon as we digitized and globalized, all R&D became global, because you want intelligence in R&D at inexpensive prices. So there are corporations which I would not name, but many of you know. They have global offices, 5,000, 6,000 PhDs in certain country. So when your scientific discoveries and everything, including engineering, is globalized, what do we do in America? That's the question you're really asking. I believe that we really need to recognize manufacturing is engineering, and we really need to invest in engineering, because now I have done this for 15 years. To take science, what I write in my papers, publication, and to put that in an 18-wheeler or what you call Class 8 trucks, it takes serious engineering, scale up, supply chain problems that we kind of understand. So today we have vaccine, but we have no vaccination. The gap between vaccine and vaccination is engineering. And so it really needs some, first, when there is a problem, you have to admit it. And when you admit it, we got to invest it. That's what in my last slide, I said that let us do engineering that matters and make sure we invest in it. But you may like saying that can you plant another tree under the shadow of a bigger tree? You just can't. The smaller tree would not get nutrients. It would not get other things to grow. So we really need to have an independent life or interdependent life for engineering, because there are no corporate houses that would do for us in the nation. Thank you.
Interesting. Let me build on that comment. I think this is, so the question though is for doing this type of work that actually eventually impacts or brings equity, innovation, engineering innovation that brings equity. People do it because, they do it not with constraints, financial constraints, etc., because they want to do it. But we as academics obviously almost always respond to resources that are being put on the table for research, and somebody else is defining the topics, or maybe we are contributing. Some of us are contributing to those topics bubbling up to the top, and agencies then put out calls. How do you change the mindset of agencies or the government that says, okay, we will support and fund research of this nature, and that's a tough problem, right? For us to actually change the dialogue in agencies which actually provide the resources that we go after to do research. Clearly, we can bring various technologies to bear to solve problems, but there has to be an incentive for us to do that. Besides kind of the just doing things because of the goodness of our soul.
I would share an observation with you that something that has happened between the traditional labs like IBM or Yorktown Heights or GE, Nishiyuan and others that has now globalized. What has happened between, there is a large body of newer funding agencies came, which is not seen by academia as funding agency, which is called venture capital. And today, meaningful lot of work is being funded by venture capitals. If you realize that just the IPOs in the last few weeks that have gone in, many of those were not funded by any government. Many of them were really funded by venture capital. So if you see Silicon Valley has their own funding agency, which is called venture capital. And it is something, the models are changing dramatically, very fast. And that's what it is important that in academics. There's one thing I found out many years before, and that was actually opened my eyes, that in the business there is a rule called 80-20, that your 20% product should generate 80% revenue. And I realized that I'm at a point that I'm doing 95-5. I'm spending 95% of the time winning 5% of the proposals. And I rejected that idea because I said, I want to spend more time with my students. They are my products. new discoveries are important to me. And that, again, that was a realization because I was just bogged down and not spending time in what is more meaningful to me.
Thank you. So there are a couple of one comment and a question. So let me read out the question to you. It's from your colleague at Purdue, Professor Ruan, Shulin Ruan. He says, thank you for an inspiring talk, Ajay. How do you think we should balance and prioritize the engineering that matters right now, in the near future, and the further future? Sometimes there is debate on whether an engineering problem matters now or for the future.
So, Shulin, thank you first for attending. And if you all do not know, Shulin has done an incredible amount of good work in energy sustainability like Parkas. Shulin, thanks for asking that question.
Well, thank you for the kind words.
Yeah. So, Shulin, my request is that, this is something actually I tell many entrepreneurs, because they want to build a company like Amazon or a bigger company. But sometimes Jeff Bezos was in his garage selling books, but they forget that. They only see the bigger buildings, shiny windows, and stock market. But they forget that sometimes HP, Amazon, some of you may not know Sam Walton, the Walmart company. Sam Walton was selling popcorn in front of 5 and dime store on Sunday so people can come and buy in his store. And this was a few decades before, not in hundreds before. So why am I telling you this? That take a problem which is the most simple but a compelling problem which is making somebody's life miserable. So I would suggest go and look around misery in terms of citizens, neighbors, relatives, population. Another good avenue that I would suggest to serve in the soup kitchen. Go in soup kitchen and just serve soup to people, those who come. When you will see that compassion and when it crunches your stomach, you work on the problem that matters. And so experiencing somebody's pain, as much as it can be hurtful, it gives the meaning then to the work. And start small. It doesn't have to be rocket science every time. But it just starts small, and that will propel ideas for it. That's how I started, and that's what I believe, that everything starts small, but you just got to start integrate that over time.
Sure. Yeah, thank you very much. Maybe a very quick follow-up. Some people may argue that the best innovation may be a little bit ahead of time, and not too far ahead of time. They say maybe the best, the timing. So it's pretty maybe tough to have the best timing. I don't know whether you have vision on that. If it's too far ahead of time, then it may not be promising. But if it's too behind, it may not be a great innovation either. So maybe follow up to the question. Right. Thank you.
Yeah. My suggestion is that, and my observation rather, I would suggest anybody to do the things what you enjoy. I'm not sure I want to be on time, or I want to be ahead of time, or I want to be behind the time. But as a manufacturing and as a maker, there are two things I can suggest. Do the things what you enjoy, including not necessarily science and engineering. And the second, if they are on timing, the market will tell. And if they are ahead of time, market will tell you too. But at least you will have fun with it. And it might sound very altruistic, but it is indeed true, because at the end of the day, even if I'm on time, that anxiety that I would get, I'm just a little behind, would be more miserable than the fun of doing it.
Mm-hmm. Sure. Yeah, thank you very much. That's great. Great vision.
So thank you, Ajay. There's a comment here from Professor Fedorov. I apologize, probably. Devesh, if you could tell us and just read out the question, a comment.
Okay. Andre, you can ask the question, otherwise I can read it. I'll come in.
It's really not a question, but I just wanted to bring to the attention of Professor Malshe and everyone that actually there is a good empirical evidence for the validity of this, what I would say, philosophical vision that he articulated. And that's always important to have data, so to speak, that supports it. And I would encourage everyone to look at this book that just came out, and I put it in the chat. It's called Dynamism, and it's written by a Nobel laureate by name Edmund Phelps, who actually looked at the data and his hypothesis on how the innovation happens not by a few, so to speak, quote-unquote geniuses who invent those technologies that change the world, but it's actually everyday people with observing eye who actually just want to make a minor change and take pride in their work that actually drive major innovation economic growth. So there's a lot of data here. So this is really high quality economics done. And this is a recent book, so I encourage everyone to read. And maybe it would help also support your argument economically with numbers.
Thank you, Andre. All right, I don't see any more comments, questions, comments. Certainly see a lot of messages thanking you for a very inspiring talk.
So Ajay, maybe I'll just follow one more question.
Sure, please.
Comes from the so when you're trying to engage community, Ajay, in these innovations, it's generally very hard with the boundaries we have in academia and economic development. They're the big walls which is there. So what's your advice and your experience on how to bridge the gap in some way, or create a new bridge across these directions through academia and community in some way?
You know, first thing I would suggest, if you're in Atlanta, so I would start connecting it to some of the local community houses. Go and talk to the community. Go and talk to the individuals, those who are in the local churches, that they provide the community support on every Sunday or every night for food. Means one of the great limitations today we have in digitization of basic education is connectivity. When we are trying to advertise 5G network, even with 3G, we can help people locally. So I think really visiting, I spent quite a bit of time in communities. I visited the parts of America that people would typically never visit, interiors of North Carolina, deltas of Mississippi, and many other places, and really visited old coffee and pie and breakfast places where you get to meet people. You really get to meet citizens and understand their pains. Visit schools. Those are highly disadvantaged schools. Talk to the teacher. Talk to the counselors. Those are advising some very difficult children sometimes. When there are students today in America, see, we believe that many a time that these problems are somewhere in outside America. I can show you a parallel America which look like, pardon my word because I don't have a better word, that's what this coin is called, third world country. I will show you a silent America that we reject to look at. And when you have evidence and data that 55% people can afford to be retirement money or whatever form of money in the stock market, and stock market is all driven by technology with hyper digital trading, connected all the way to the education and medical delivery by digits, where we leave the rest of the society. And so going to this, I think meeting people, and this COVID-19 pandemic would have hit, I would have visited in parts of Indiana where there are food insecurity challenges right now. So again, find the ways to immerse yourself. And that's what I decided to write REST proposals and spend more time in the outside, because it kind of restricted me to computers and offices, and I wanted to spend more time outside.
So Ajay, a comment regarding that. So it's certainly true, perhaps some of us can afford to do that at the stage of our career that we are in, but when it comes to young faculty who are starting out, who of course are constrained by the system that we have, what kind of advice would you have for them to actually, do engineering research? That matters, but obviously still be successful in the system that they are actually working in.
Yeah, no, this is a very practical and good question, actually. And what I found out that, you remember, many of the people on the call write grants like from National Science Foundation. We have intellectual merit and broader impact. What you write in the broader impact, do spend time on that. That's the only advice and suggestion I will give. Because I really genuinely don't know how much percentage of time people spend in broader impact. But that takes exactly almost the same real estate as intellectual merit on the front page itself. And if it is that, your broader impact need to be proportional. And the second, when you come beyond even full professor, chair professor, whatever role you want to do, at the end of the day, what is going to matter, and the world is going to ask you, what was the impact of what you made? And if I give them my citation index and other common person, they don't understand. But you have to understand one thing: they're paying taxes, and that tax pays my research. So I have certain accountability issues.
Mm-hmm. Yeah, interesting. Other questions? I see people on the call, the calls still, so please feel free. I can certainly continue this conversation.
Ajay, I put this question in the chat box also, but I wanted to ask you your thoughts on the role of colleagues who go to business schools and sort of think of entrepreneurship as the realm of business schools versus engineering schools.
Yeah. Thank you, Jay, for asking. I will tell you my own story. So I reached to a point in my entrepreneurship career, and I was seriously thinking of taking executive MBA. And so I asked my colleague, in fact, at that time I was business manager. He was a graduate from Harvard. And so I asked him that, hey, Greg, what do you think? I'm thinking about doing executive MBA. And he said, you don't need to, because what we study as case studies is what you're living 15 years. So you don't need to spend no dime for 200,000. So that is a light kind of comment set aside. Jay, I think the key is that whether you go to business school or not, the key is that can you translate your research? And if I can take the translation of my nano-engineering, I'll tell you my own story. Nano-engineered particles of inorganic material at the lattice level, at the lattice scale, putting the strain and expand that lattice at nanoscale and inserting multifunctional molecules in that lattice and creating organic and inorganic intercalated macromolecules. That's what I've done. Great papers, very nice. But what I really found out that it has a huge applications. If I can put that in a box, in a can, in a tube, or in the liquid, that can be applied, and I can tune them, dial them for oil and gas, 18-wheelers, or somebody else, or electric vehicles. What I found out that the engineering of that science, what I discovered. So I do not say that business schools are less or more important, but it is the skill sets, but it is the vocabulary, it is the language. So one may not go to business school, but if you, what I would call quote unquote, hang out with business people, they change your thinking. And that's what happened in my case, that spending enough time with business people have changed not only what I do, but what I think. And so there is a merit to each discipline for a purpose, but translation of science to engineering and engineering to impact is what I'm interested in. Thank you, Jay.
Thank you, Professor Malshe. We still have a few minutes, so right, Devesh?
Yes, we have a couple of more minutes. I'll just ask one last question, maybe.
Please do. Please do.
So it's still for junior faculty, as Shreya said. Yes, they will write something about community engagement in their awards. It's always hard because of promotion tenure process. But let's think about people who are now associate professor who wants to think about bigger areas, bigger things. What career advice you have for them to think about some of these things which might not be aligned to the institute priorities in some way for promotion tenure, but still aligned to bigger impact priorities which you have for their career and what science can do?
Stay with the area that makes you happy. That's what I would suggest, because I found in my career of last, I sound very dated now, but every 4 years there is a new hype. Sometimes it was superconductivity, diamond-like carbon, MEMS, nanotechnology, AI, additive printing. I can just go on and on. There used to be amorphous silicon. It is like a technology fashion show. That every 4 years there is a new fashion, and after 9/11 there was a solicitation on sensors, and everybody steered their ship over towards that direction. And be a ship who goes in the opposite direction, if you believe in. And I will tell you, some of my research that has done the most impact, it was rejected by reviewers pretty seriously with comments that it is one of the worst proposals they read. But that has given the most impact in engineering. I can show you the evidence. So I don't know how the reviewers do justice, because they are also they come from their past. They're nice people, but they come from their past. They have their own constraints. So my philosophy is always, I don't evaluate myself with the grants I have, but I evaluate myself how much exciting and somebody is feeling good about that they are going to get it or work with it or happy about it. So that's what matters. So it doesn't fit in the traditional criteria. It is a huge risk. And what I would suggest, every 5 years, change the application area you work in. Because at some point in time, you become preacher. And once you become a preacher, it is very difficult to change your profession. So so 2 years before I decided to stop working in nanotechnology, I decided to stop everything what I'd done before, and I started getting involved in food, agriculture, 3D printing of food, manufacturing in space. It is a huge risk, but you just got to, I've done this few years before that. So every 5 years I change the application area because I learned something new. And then I connect more dots than average. Mm-hmm. And it may not be for everybody, but it is exciting. It is scary sometimes, but exciting.
Well, I couldn't agree with you more, Ajay, on that note. I think all of us always want to be learning. We are, perpetual students. We are always learning new things, and one way to do that, of course, is to venture into new areas. And while it's scary, I think with time we tend to actually weather that much better. So certainly I've benefited from it personally, and so I certainly attest to what you said. Well, I think that brings us really to the end of a very interesting, stimulating presentation and discussion. If it wasn't what you thought it would be, I still hope you walked away inspired and reconsidering some of the things you do. But it's been my honor and pleasure to serve as moderator. Thank you all for staying here till the very end. And thank you to Devesh. I'll turn it over to Devesh and Partha for them to conclude this seminar.
Just thank you, Shreyas, and thank you, Ajay. So
I would like to echo the same. Thank you, Professor Malshe. Thank you, Professor Mulcott, and also all of you. Have a great weekend. And thanks, Devesh, as always. So, all right. Bye-bye.
Okay. Take care, everyone. Bye-bye.
Thank you, Devesh.
Bye, Ajay.
Thank you, everybody.
Bye.
Bye.
Thank you, Partha.